Good afternoon. So I'm David Byrne, based in Singapore. Some of you may have met me or heard of me before. So I'll be spending the next hour to give you not exactly a tutorial, but I just wanted to clarify exactly what you get with each of the different Creo simulation products and basically what they look like, because I find there is a degree of overlap between these products, so people get a bit confused about what they've got. Even people who've already got the software sometimes get confused about what they've got. So I'll be running through and I'll be alternating between kind of PowerPoint explanations and showing you some live demos. I hope you find that useful. So it's not going to be a specific tutorial for you to learn how to use a particular piece of software, but hopefully it'll give you a good feeling for what the different tools are, what they look like, and what you can do with them. So yeah, so I'm saying this can be a Creo simulation product overview and comparison. The first thing that I always need to explain to people, that I guess people should know, but often don't, is that every copy of Creo includes a simulation capability. This is what we call simulation essentials, sometimes called simulation elite. And every copy of Creo, I think for probably the last 5 years at least, has this included. And this includes a basic linear static finite element analysis capability, which can be used by all users. But during this afternoon's presentation, I'll be going on to show you the various enhancements to this basic capability. I would say the first level of enhancement is what we call the Creo simulation extension, or we often just refer to it as Creo Simulate. And this provides a much more expanded range of capabilities for structural and thermal finite element analysis. Again, for people who are doing more challenging applications involving nonlinear analysis, dynamics, and all kinds of advanced applications, we also have something we call the advanced extension. And it's kind of like the previous one, but with some extra bits added on. So I'll explain what the differences are as we're going through the presentation. I'm also going to be introducing some of the newer Creo simulation products. You may have heard of Creo Simulation Live, which is our real-time simulation, which uses the power of a GPU instead of a CPU. This is actually jointly developed with Ansys, who are basically the world leaders in simulation software. So this is a very powerful tool. And I'll also be going on to show you another new tool, which is jointly developed with Ansys, which is essentially the very famous Ansys mechanical FEA solver embedded into Creo. Now, Ansys Mechanical has been around for more than 50 years and is pretty much, I think it is basically the leading mechanical analysis software in the world, at least high-end FEA. So you can now get this inside Creo. The new flow analysis or computational fluid dynamics software, which can simulate fluid flow and heat transfer. And then also, again, if there's a time at the end, I'll show you the topology optimization software. So the first thing to mention, well, I've been selling Creo and its predecessor since 1991. And when I started in 1991, it was then called Pro Engineer, and it already had some simulation capabilities. In fact, it had a version of Nastran embedded in it. But the Creo Simulate software that I'll be showing you in a few minutes now was actually added in 1995. And I was, from 1998 to 2001, I was one of the product managers for the Creo Simulate product. So Creo Simulate has two levels, what we call basic or standard, and it has the advanced capability. And this is a very powerful software. It's the oldest software currently available, but it actually has the widest range of capabilities. I'll compare them at the end, but just keep in mind that this is, you may have heard of this before, but it's actually still the most powerful simulation tool that we have available within Creo, at least for structural and thermal simulation. So Now, this new generation of products, which came in since about 5 or 6 years ago, many of them have been jointly developed with Ansys. So we have Simulation Live, Creo Ansys Simulation, Creo Flow Analysis, and GTO are actually not with Ansys, but they're based on other companies that PTC bought in. So let's start off by looking at the Creo Simulation extension, or what we usually call Creo Simulate. So the Creo Simulation extension can do static analysis, modal analysis, buckling, steady state thermal, and sensitivity and optimization studies. It assumes linear materials, that's things like linear isotropic materials like metals, engineering plastics, things like that. So it can't do some types of nonlinear applications, but for linear applications, it's very powerful. And in addition to regular solid analysis, it can also handle idealizations, things like shells, beams, masses, springs, screws, etc. So it's very powerful software. Now, I mentioned earlier, just before we move ahead, that there is this essentials package. You can say that the essentials package is just the first part of the simulation extension. So it only allows you to do static analysis, though not including contact. So every copy has this Creo simulation extension with static analysis, but when you actually purchase the extension, you get the much more comprehensive range of capabilities. But certainly, I believe that the best value package is actually the advanced simulation extension, because this adds a lot of additional capabilities. We can do advanced contact analysis, including sliding friction, large displacement analysis, nonlinear materials, pre-stress analysis, and various different types of dynamic analysis. These can be a time domain, frequency domain, random response, shock analysis. And also the thermal analysis capability that's in the standard package is now transient in the advanced package. And we also have various other supporting things, advanced material models, more advanced idealizations, things like screws, bolts with pretension, all kinds of things like that. And also from this version, you can also export models directly into Nastran or Ansys if you want to. So let's switch over quickly to looking at my Creo screen. Anyway, so let's just load up a very simple model that I have. So this is a bracket, and I'm going to do a stress analysis on this bracket. Now, this bracket, in fact, is not originally a Creo part. It's actually an imported feature. And I've used actually the flexible modeling capability in Creo to make some changes to this model. We'll see later that I've created a bunch of flexible modeling features that I can actually use to change this model. Okay, so sorry, that one. Okay, so let's just have a look at this. So I've got my CAD model here. In fact, you can already see some constraints and boundary conditions, but I'm going to go through into the Creo Simulate model. So I go Applications, Simulate, and now you can see that the menus, the top ribbon menus, have changed. And you can see up at the top left, you can see I've now got two modes. I've got structural mode and thermal mode. I've got various different types of load that I can apply. And in fact, there's more shown on the drop down. We have a pretty comprehensive range of load options. We also have a range of constraints. And again, there are other ones not shown here. And all of these can be set up either in world coordinate system or local coordinate systems, user-defined coordinate systems, things like that. We have the software comes with a library of materials that we can use, so we can load our materials from this library, and that's the kind of the basics that are that we've shown on this main ribbon here, but we can go to the second tab on the ribbon, and now we can see Refine Model. So this allows us to do various refinements or add in additional what we call simulation features to our model. These are things like beams, springs, lump masses, shell elements, contact elements, welds, links, fasteners, that's, screws and bolts and things like that. And we also have automatic meshing here and various mesh control options. I'm just going to leave it on automatic for these settings here. So now one of the really nice things about Creo Simulate is it works very well together with a flexible modeling. You notice on my geometry here, I've got kind of a tab there. That may be on for some reason, but say for instance, I just wanted to get rid of that for some reason, I can just click on that and I can just say remove, and it will remove that feature. Now, bear in mind, this is not a Creo model, so that was not a Creo feature that was created in Creo, but I'm using this capability called flexible modeling, which allows me to make these kinds of edits to the model. So actually, I'm just going to undo that. So let me just go and find that remove feature. By the way, that remove feature was created in simulation mode. So if I go back into CAD mode, it's actually still there. So one of the nice things in Creo Simulate, we can have models that have different versions that are slightly different from the basic CAD design. Because often when you're doing these types of things, you want to make some changes for the simulation model. So anyway, I'm just going to bring that back. And then you can probably see if I zoom in down on the left-hand model tree here, let me just show that. I've got my constraint and my load. So let's just have a look at those. My constraint is that the two holes at the left side are both fixed, and my load is a negative load of 1000 newtons in the minus z direction. So this is a pretty typical setup for a static analysis. We have constraint, we have load. I can then come on to define my analyses. I've currently here got a static analysis defined, so that's just my constraint and my load. I've also got a modal analysis defined, so I'm going to look for the first 4 natural modes for this analysis. Now I've just done those 2 for this example, but you can see here, if we had only Creo, the Essentials package, we'd only be able to do the static analysis. But if you have the standard Creo Simulate standard, you can then add on modal and buckling. There's actually a separate module for fatigue analysis, which we're not covering here. But then if you want to do the more advanced dynamics and nonlinear analysis, that's where you need the advanced capability. So I've actually already run my analyses here. Each analysis actually only took about 3 seconds. I'm running on an 8-core laptop, so it's pretty fast. So I'll just load some results to save time, and I'm just going to load a simple results window template, and now I can see my results here. So I've got on the left-hand window, I've got my displacements, and let me just animate that a second so you can see my displacement on the left, and also I've got my stresses on the right-hand side. If we want to know for this window where is the maximum stress in the model, we can see it's down in this region here. Nice thing here, I can tie my 2 windows together so I can kind of zoom in and out on these things at the same time. So these are the results from my stress analysis on the original bracket design. And just keep in mind these 2 numbers, or I've actually written them down, you'll see them in table later. My maximum displacement in this case is about 0.48 millimeters, and my maximum stress is about 84.7, something like that. That's megapascals. So I've got these results. I can also show you, let me just turn off that tie again, a moment. Yeah, so I'm just going to close these, and I'm just going to also compare the modal results. So these are the results from my modal analysis. Again, let me go and tie these together. And so I can see all of my modal results, and I can come and see the various natural modes here. I can see that at the top left, I've got my natural modal frequency of about 254 hertz. That's this number here. And then I've got my mode 2 at 1042 hertz, my mode 3 at 1756 hertz, and my mode 4 at 1784 hertz. So I'm not expecting you to remember these, but I will come back and show you them in a table earlier. And again, this analysis only takes about 3 seconds on my laptop. So that's an example. Now, you can also go in to do thermal analysis here, but I haven't set this one up for a thermal analysis. It's just a lump of metal, so it's not particularly suitable for thermal analysis. But you can see here that when I switch into thermal mode, you can see that along my top ribbon, I have heat loads, I have heat boundary conditions like temperature, convection, radiation, etc. And I can run both steady state and transient thermal analyses. And one of the nice things is we can actually take the results from a thermal analysis. Let me just go back to structural mode, and I can actually take the loads from a thermal analysis, and I can read them into the structural analysis, so I can look at thermal stress. And if I've done a transient thermal analysis, I can actually choose the time. Transient analysis, we're obviously running over a period of time. So if I've done a transient thermal analysis, I can actually choose the time at which I want to analyze the thermal stress, because these things can vary over time as things heat up or cool down. Okay, so that's a typical example of a simulation using Creo Simulate. So I'll just switch back to my presentation a moment now, and now we're going to look at Creo Simulation Live. So what is Creo Simulation Live? It's a real-time simulation tool which uses the power of NVIDIA GPUs and the Ansys, and the solver is from Ansys. So my laptop, as I mentioned, has an 8-core CPU, but I've got a GPU with 1,000 cores in it. Now, it's not that simple ratio. It's not going to go, more than 100 times faster, but it goes at least 10 to 20 times faster using my GPUs. So what can this do? Well, we can do stress analysis. You can see my same favorite bracket example. We can do thermal analysis, and we can do modal analysis. And we can also, in this software, we can do something that Creo Simulate can't do. We can actually do fluid flow analysis. So I'll show you some examples of these in just a moment. Now, I've still got the same model up here, as you can see. So this time I'm going to switch into, you should be able to see it along the top there. I've got this additional tab for live simulation on my main menu bar there. So I've gone into live simulation, and in fact, I've got the same setup with the same constraints and loads, the same analysis definitions here as I had in Creo Simulate. So everything is set up the same, except this time I'm running with my GPU solver. So I'll just press the Simulate button here. It's starting off doing the stress analysis, and you can see it's already got results. And we're just seeing this. We don't need to go into a separate results post-processor. We're seeing this in the ordinary Creo window. I can see my displacements here. I can see my stressors. And I think, okay, that's all right. I can see, oh yeah, there's a stress concentration down in the corner there. And then what's really cool about this software is I can go to make changes to the design. So for instance, I just actually resumed some features I created by the flexible modeling. And you can see now, actually I should roll it back. Let's just keep track of the stress for the original model was up at about 83. If you remember in Creo Simulate, this was 85. Here it's 83.6. But that's a pretty high stress. So what I'm going to do is just make some modifications to my geometry. And you can see more or less immediately the stress is going down from almost 84 to 69. And I can do various things. I can also go in just to make other changes to my geometry. So I can pick on a bit of geometry. I can pull it down. Let's pick on another one here. Oh, sorry, I need to do that one first. Let's just pull that one down a little. Let's go and pick on another thing here, and I'm going to rotate that slightly. So I'm just making these changes interactively on my model, but every time I make a change, it updates the results. And you can see now that my stress with those small changes has come down from about 84 MPa down to 51. But if I decide I don't want to keep those changes, I'm just going to go back to the original model now, because I want to see also how those changes are going to affect my modal performance. So going back, I'm going to switch into a modal study. And notice I'm actually, the solver is running continuously. This model is continuously being analyzed on the GPU. So every time I change the geometry or change the simulation settings, I could change the constraints or the loads. It's always being updated in pretty much real time. So, so I can see my mode 1 here. Let's just look at this. It's kind of wobbling from side to side slightly. Let me just emphasize that so you can see it a bit more clearly. Let me go on to looking at mode 2, mode 3, mode 4. So I can very easily switch between these analyses. So the main advantage of this software compared with the Creo Simulate is that it is very, very fast and you can make these interactive changes. However, I do need to explain that it doesn't include many of those advanced capabilities like advanced loads, nonlinear analysis, dynamic analysis, etc. Okay, so I'm just going to switch back into this one a second. And again, I've now gone back to my static analysis. So now just to show you some of the other things we can do, I'm just going to close this model a second. So I'm going to come on to open up a heat sink. So this is now going to be live simulation for thermal analysis. So I've got a heat sink here. Let me just turn off those things saying, oh yeah, sorry, okay, got it. Let's just off those a second. Right. What am I doing? Just a moment. I want to hide those. Yeah, sorry, wrong button there. So I've got I got my thermal analysis here. I've got an aluminum heat sink. And it's got a chip on the bottom. I can see on that chip I've got a heat load of 10 watts. This is typical maybe of a small CPU. This has got a small heat sink, but we've got that. And I can do my analysis now. I can do simulate, and you can see that I've actually measured, I've got a couple of probes here. One is measuring the maximum temperature on the CPU, and the other is measuring the temperature at the top of the fins. on this heatsink. Now that temperature on the CPU is reaching around 108 degrees, which is a bit too hot. So what I'm going to do now, I'm going to make a change to the length of the fins on the heatsink. You can see at the moment, those are 25 millimeters long. I'm going to make them 40 millimeters long and regenerate the model. Just a moment, what am I doing? Regenerate. I've done something here. Okay, yeah, sorry, it 40 regenerate. Sorry, I'm missing something here a moment. Why is it not regenerating? Sorry, let me just erase that a second. I think I clicked on the wrong button somewhere, and I'll just load that in again. So hold on, got my heatsink, and I'm going through into live simulation. Yeah, I've got that, and I want to change the length of the fins on my heatsink. And that's okay, that's working now. I clicked something in the wrong place. And now we can see that the temperature on the CPU has come down to about 86 degrees. I think for most Intel CPUs, the maximum operating temperature is supposed to be 85 degrees. So this is pretty close to meeting the design requirements. So this is my thermal analysis. And there are various other things that I can do. Let's say we have various different types of thermal boundary conditions, but I'll just leave that example for now. So I'll now go into showing you what we can do for flow analysis. So I'm going to open up an example here. Now this could be something like a catalytic converter or a filtration unit. I'm actually using the gyroid the gyroid type features that we've had in Creo for the last 2 or 3 releases. You can make some very complex structures with these. Now, as you can see, this is very, very complex geometry. If I was to mesh this in a regular CFD software, this would probably take 4 or 5 hours to analyze on this computer. But I'm running it here, I can do this in just a few minutes. So let's just look at the boundary conditions here. I've got a flow velocity of 5 meters per second at the inlet, and I'm going to set a pressure of 0 gauge pressure, that's atmospheric pressure, at the outlet. And I'm just going to assume an isentropic flow for the moment. So I haven't put any heat exchange boundary conditions on, but we could do that. So I'm just going to press my simulate button, and we can see here how it's taking a few, because it is a complex geometry, it's actually loading it into the GPU now, but we'll see something coming up in a few seconds. Okay. So now we can see the flow starting to develop through this complex lattice. By the way, I'm only looking at the fluid parts now. I'm not looking at the solid. So that's why we're not seeing the sides of the box. So there's many different ways I can visualize this. I could visualize this in terms of streamlines. So this is some streamlines running from the start to the end, showing the path. They're actually spreading out pretty well through this lattice. I can also show this in terms of some particles. We can actually see particles animating. And because this is such a complex flow, it's pretty difficult to visualize this. But if it was a simpler flow through a valve or something, or a pipe, we'd be able to see this much more clearly. Another way I can visualize this is using vectors. let me just check some settings there on the vectors. And again, I can come to see, let me just increase the number of vectors there. Oh, not too many. And yeah, I don't want the tails too long. So I can actually also, again, because it's a very complex flow here, it's quite difficult to visualize things. But you probably get the idea. We can also just do plain old cut planes. So I've got a cut plane here, and I can go to pick on that. So I can, where are we? Fluid objects, feature. So I can take my cut plane and I can look at the model on various different sections, or I can rotate it to look at it that way. Let's just rotate this back a second. Put that down to 0. Yeah. Okay. So I can do that. And also I can do this thing, what they call a direction field analysis. This is also in CFD terminology, this is what's known as a line integral convolution. And we can kind of see the flow patterns here, and we can see where, particularly where recirculation regions are occurring. Incidentally, at the moment, I'm looking at the velocity, but I can also go and look at other quantities like pressure and so on. So yeah, so sorry for this one. I can see the pressure at the inlet, the pressure at the outlet, see how it's varying through the structure, and I can go to pick points throughout the structure, and I can go and create probes. These can actually be saved and become permanent features, so we can set up permanent monitoring points. All right, so lots of things there we can do on flow analysis. And this can also, in the latest version, Creo 10, it can also do conjugate heat transfer. So we can actually do fluid flow analysis, including heat transfer and including heat flow through the solids. So this is what you require for applications like electronics cooling. If you really want to simulate the fluid flow through electronics assembly or around a heat sink, etc. Okay, Creo Ansys. So this is the most recent of the new products, Creo Ansys. As the name suggests, this is jointly developed with the Ansys company, and it's essentially a version of Ansys Mechanical, a kind of a light version of Ansys Mechanical integrated with Creo. If you know Ansys, you'll know that it comes at 3 levels: Pro, Premium, and Enterprise. This is more or less Ansys Mechanical Pro, but integrated into Creo. It has a kind of a common GUI. It has the same GUI and settings with actually Creo Simulation Live, so you can share your loads and constraints and things like that. The big advantage of having Ansys inside Creo is that it's fully associative. So if you make any changes to the geometry in Creo, then it can automatically remesh and rerun the simulation. You can do that with Ansys Mechanical, but it's just not nearly as convenient as if you actually have Ansys Mechanical embedded in Creo. So this allows you to do structural analysis. You can also do thermal analysis. In future, they plan to also support fluid flow analysis, but at the moment, it's essentially structural analysis, thermal analysis, and also some dynamic analysis, modal analysis, but it doesn't have full dynamic analysis, things like vibrations, but it does support nonlinear analysis. So it's a pretty powerful package. And it has its own meshing. It has a special mesh built in, which is very robust, can handle very complex geometry, very large models. And it provides all of these, I say, these Ansys Mechanical capabilities, but in a rather kind of more convenient and easier to use format. So I'm going to go back to open my favorite bracket model. Sorry if this one's a bit boring, but it's a convenient one to demonstrate and also to compare the results. So I've got my model here. So now notice actually I do actually have in my Creo, I can also link directly to Ansys Workbench or Ansys Discovery, but that means connecting to the external Ansys software. So I'm just going to do this directly in the Creo Ansys simulation. So that's just there on my applications bar under Ansys simulation. And oops, I've clicked out of it. Okay, back in it now. So you can see I've got the same static analysis, I've got the same modal study set up. So I can go to, and in fact, it's already, I could run this, but it takes a few seconds, but I'm not going to tempt fate. So I'm just going to show you what the displacement looks like. And again, we can see we can do some animation here. Got the animation. I can also switch to showing you my stress analysis. Again, zooming in here. I don't know if any of you are keeping track of this, but oops, right, I didn't zoom that right. This one is showing about 82.6 as the maximum stress. And just again, back to the displacement, it was 0.482. And I've got these results. We can go, if we've got these results, let me just go into the more advanced version here. And if we're interested to see what the finite element mesh looks like, this again is using automatic mesh generation, although I have changed a few of the default settings for this model, you know, the maximum element size and things like that. But it's handling the geometry pretty well. If I wanted to analyze that, for instance, that change in geometry, I'd need to switch back into CAD mode, modify the geometry, and then come back in, and then I could basically just press the run button, and it would then remesh automatically, rerun my solver, regenerate all the results you can see here. All right, switching to the modal study, let's just look at some of the modal results. Again, I can see my modes here, so let's just activate mode 1. And we can see again my mode 1 here. So we're doing all the same types of things that we saw in the previous solution. One of the big differences here, though, so I've got my different analysis types. We can also instantly go to, you can see here the simulation types available. It's structural, thermal, and modal. I haven't done a thermal for this one again because this part is not really suitable, but we have more or less the same capabilities for thermal analysis that we do. Let me just actually go to set up a thermal there. And we have the same types of boundary conditions: temperature, convection, radiation, heat flux, heat generation, etc. We have the same type of simulation capabilities as we have for the other things like Creo Simulate and Creo Simulation Live. Let me just delete that 1 second because I don't need that. Now, the nice thing about the software here, you can actually do a lot in this package. It has a pretty wide range of capabilities. We can see here, again, we've got idealizations, we've got masses, springs, shells, beams, contacts, joints. We can go in and do advanced meshing operations. But say, for instance, there is some type of advanced analysis that I can't get in the basic Mechanical Pro module. So what we can do here is there is this option here. If I just zoom in, export to Ansys Mechanical. So this will actually export to Ansys Mechanical, and I've got one. It takes a couple of minutes for the export. So since we're running short of time, this is actually Ansys Workbench. And you can see here, I've got my static structure analysis and I've got my modal analysis. And I can just open up these in the full Ansys Mechanical package. So you should see in just a second. Okay, so now we're seeing the full Ansys Mechanical package opening up, and I can do the same type of analysis, but obviously you can see this is a much more advanced analysis tool, and we have you know, literally hundreds of different analysis options in this software. So this is for more expert, for more advanced users. This is the stress and deformation results. Again, I'm keeping track of these and I'll show you in a moment. I can also look at my I can look at my modal results. So again, I can show you my modal results. So I've got my mode 1. Let's animate this fella. And you can see down the bottom, there's actually a little table of the frequencies that we get out. We'll come back to compare those in a moment, but I can switch between visualization of the various different modes. So this is pretty nice. I can also get all the detailed Ansys information about the model if you want to, if you like that kind of stuff. So this is a very comprehensive analysis capability, and as I say, it's just available as an extension to the Creo Ansys product. So particularly if your company is using Ansys, but using Creo and Ansys, this actually makes a great preprocessor or modeler for working with Ansys. So let's just actually have a look. Now I actually went through this morning and I was keeping track of all the different results for the different software we've seen. So I've got the results here for Creo Simulation Live, Creo Ansys, Creo Simulate, and also comparing to Ansys Mechanical. Now, one thing you would notice, by the way, is that if you compare these two, Creo Ansys and Ansys Mechanical, the results are identical, and you would expect them to be because it's actually it's the same solver, the same mesh, everything like that. But if we compare these other quantities across the full range here, so let's look at the maximum displacement. We're seeing one what the last significant figure. So that's 1 part in 500 roughly. So what's that? That's about half of 0.1% variation. For stresses, we're seeing a bit more of a variation, but we're still seeing pretty much less than a 2% variation in stress. Mode 1, again, we're seeing this. This is 0.1% variation. Mode 2, again, it's about 0.1%. And again, mode 3 and mode 4. So what I wanted to show you is that basically all of these software, at least for a standard benchmark, they all get almost exactly the same results. So all of them can produce very high quality results. So you might say, oh, well, if all of them produce the same results, how do we choose between them? Well, we choose between them based upon the functionality we need and also perhaps in terms of price. So what you can see here, I've got this table comparing what you get in the Creo Essentials package. So this is what you get with every copy of Creo. This is what you get with Creo Simulation Live. In fact, yeah, they've now just added contact analysis in the latest version, version 10. And also there is an update. There is a Creo Simulation Live Plus, which also gives you the fluid flow analysis capability. Just bear in mind that this is the plus option. So back to what we saw earlier, we saw Creo Simulate Standard, again, pretty comprehensive range of capabilities. One thing I'd like to point out here is the design optimization is available. You can do that in Creo Simulate and Simulate Advanced. So we have this optimization capability that's in these more advanced ones. You'll see that, in fact, in terms of structural FEA functionality, the Creo Simulate Advanced is the most powerful package because we have things like dynamic analysis, that's vibration, shock, etc. And we also have transient thermal. But we don't have fluid flow or real-time simulation. And then in the Creo Ansys package, this is what we have. But of course, if you export to one of the more powerful Ansys packages, you can get those features. So if anybody wants, I can give you this chart so you can check out the comparison. So I just want to quickly mention our other tools, flow analysis, which allows us to do CFD. We have actually 3 levels of the flow analysis package. Kind of the basic flow analysis, we have flow analysis plus and flow analysis premium. So depending upon what sort of CFD you want to do, we have this capability. Just to show you what that looks like, let me just go and load an electronics assembly. So we can see here is an electronics box. It's got an aluminum case, which I made transparent in the middle, but it's got a number of components inside. It's got chips, transformers, capacitors, power transistors, and there's a fan at the outlet. So I can switch from here into my flow analysis mode, and I'm just going to open a project that I previously saved, and I'm also just going to load the results to save time. This analysis takes about 5 minutes, but we don't have the time now. So let me just go to, I'm just going to turn off the display of the body here, and let me just turn off a couple of other things. So let's off that a second. I'll show you these one by one, which makes it easier to understand. All right, so I've got the, you can see actually there was actually a flow of 1 liter per second, that's 0.001 meter per second specified at the outlet, and there is ambient pressure and temperature specified at the inlet. Let me just change from Kelvin to centigrade. So actually, we're coming in at about 26 degrees centigrade. So now, as you can see, as I move my cursor over these parts, you can see the temperatures. I'm actually going to select all of the parts at the same time. So now you can see the temperature distribution within this unit. You can see which components are getting hot. I can see the heat signature there. Now, to understand the way in which things are flowing, you probably saw streamlines earlier on, so I can set these streamlines to actually visualize the flow. Where are we? Yeah, okay, so you can see the way the air is flowing through the streamlines. The streamlines can actually be colored by temperature. So they're actually changing in heat, obviously, as the air is going through the box. It's changing in heat. Other ways I can visualize, I can go to look at a cut plane plot. So I'm looking at a slice through the model, and this slice can be moved up or down through the model to look at the temperature on different sections. And another nice way to visualize hot regions is with a temperature isosurface. So say, for instance, I wanted to see any regions which have a temperature above 65 degrees centigrade. Now I can see that it's these components. There's actually a transformer, and there's 2 sets of power transistors with heat sinks, and these are actually the hottest components in this design. All right, so that's the Creo Flow module, and just very, very quickly, I'm going to close this one, and I'm just going to try and finish off generative solutions. So I'm actually looking at GTO. So this is our generative topology optimization software that I'm looking here. And there is also, in case you've heard, that there's another related product called GDX, which is a web or cloud-based system, but I'm not going to be showing that today. What I often do for these types of analysis, I'll just go into Creo Simulation Live just to do a quick preliminary understanding. Where is the stress? What are the displacements like? See that. So I got some idea, but this part is actually very low stress in most of the main bracket parts, so it can definitely do with optimization. So I'm going to go into my GTO module here. I've already split this part into multiple bodies using the new multi-body design capability features in Creo. I think that's been in since Creo 8. And we have these regions we call preserved geometry. This is around the loads and the constraints. These are regions that we know the shape needs to remain fixed. But the overall, this kind of transparent region here, what we call the envelope or starting geometry, this is actually where we can let the software decide how much material to leave. So I've got the setup of loads and constraints that's appropriate for this model. I can set up my design criteria, which is to, in this case, to maximize the stiffness but minimize the volume. And I've also set up a manufacturing constraint of symmetry. There are other manufacturing constraints. So for instance, for 3D printing, I could choose a build direction. For high pressure die casting, I could choose a parting line. For pocket machining, I could choose an extrude type shape with draft angle. So I can choose all these options, but I'll just leave it as it is. And I'm going to run this. As you can see, it's optimizing very, very quickly. It's finished. And we can see here the stresses. We can see here the displacements. And I'll say, OK, that looks good. Now, the really clever thing here is that this is currently a finite element model, but I can now tell it to convert back into a CAD model. So I'm going to now have it create a new Creo part. And it's basically creating a freeform surface, wrapping it around the optimized geometry, but also intersecting it with the original keep regions. Those are the cylindrical regions around the part. I'm actually just going to make a small suppression here because there's a feature I don't want. But we can see here we have a beautiful CAD solid. For those of you who maybe have used Creo, this is a freestyle surface. And one of the nice things about freestyle surfaces is we can actually go and pick on a surface, and I can say edit. So I can pick on that surface, and then I can say, oh, now I would like to modify that surface a little. So I can literally just go in and pick surfaces. I can model, I can drag them, I can blend between them. I can do all sorts of modifications on them. And then this is now a modified CAD surface.